afternoon, students. Today we are going to take the fourth experiment of the analysis of plane truss, where we are going to analyze the truss by using the two conditions. Okay. So here you can see the problem statement, which I will read now. Analyze the plane truss as shown in figure by stiffness matrix method for the following condition. The first condition is temperature increases by 50 degrees Celsius, and the second condition is element AD is 5 mm long due to error in fabrication. For that, you have to take the value of alpha, that is the coefficient of thermal expansion, 12 into 10 to the power minus 6 per degree Celsius, and the value of the modulus of elasticity is equal to 200 kilonewton per mm square. Cross-sectional area for each member is 500 mm square. Okay. Now, as we have seen in the theory, we have analyzed the truss for both the conditions. The same conditions we have to analyze the given problem using the stiffness matrix method, and that we have to compare the result with the software result. So these two conditions we have to analyze the truss. So here you can see the problem figure where the truss is given, and you can see that there are total 4 members for the given truss, and you can see that the two are the hinge support, one is the roller support, and at the free node there is a loads are acting, that is there is a nodal load acting at joint D. Okay, so this is a given truss. So first of all, you draw this problem in your copy so that it will be easy to you to model this truss in the software. Okay, so now we can, first of all, what we are doing, first of all we are finding out the coordinates of the various nodes. Okay, so when you are solving this problem analytically, first of all we are drawing the skeleton diagram where we are showing the node number, member number, and arrows like that. So as you know that the degree of freedom for this structure is 3. Okay, 2 possible displacement at node D and 1 possible displacement at node C in the X direction. Okay, because it is a roller support, so it is restrained along Y. So there is a 3 degree of freedom. 3 displacement you will get, nodal displacement you can find out. Okay, so first of all we will find out the coordinates of the node. So here I have written this. You write down this in your copy. So always the bottom node we are considering it as the origin. So always the origin we are having the coordinates for the origin is 0, 0, 0. Then coordinates of node B. Okay, or you can give the node numbers. First of all we are giving the bottom node, then the top node, then bottom node. In the left node we are giving node 1, in the right node we are giving node 2, the top node in the left hand side node C we will treat it as node 3, and node D we will treat it as node 4. Okay, so bottom node, node A, coordinates of node A or node 1, it is 0, 0, 0. Coordinates of node B or node 2, it is 4, 0, 0. Okay, and the coordinates of node C or node 3, it is 0, 3, 0. You can find out from this figure. From node A you can calculate the vertical distance, so there will be only Y coordinate, there will be no X, there will be no Z. Then the coordinates of node D, from A you have to calculate that distance. So X horizontal distance is 4 and the vertical distance is 3. Okay, so the coordinates of node D or node 4, it is 4, 3, 0. It is 4, 3, 0. Okay, so these are the coordinates of all the 4 points. You write down it in your copy, draw this figure so that you will be very easily model this truss in the software. Okay, so this is the experiment number 4 where you have to analyze this truss for these two conditions. Both the effect we will consider in one problem temperature increases by 50 degrees Celsius and element AD is 5 long due to the error in fabrication. Okay. Now I will start the window of Stat Pro. Okay, and here you can see the project task. We have completed the 3 experiments of this using this Stat Pro. So I think you'll be able to know that how to go with the first task. What is our first task? Our first task is go to the new project. Okay. So we click on new project. Okay, now once you click on new project, there will be the option of new model, from where you have to select the option of truss. Okay, because there is option of truss. While analyzing a beam, we are selecting the option of plane to dimensional structure. While analyzing a truss, we are selecting the option of truss. So click on truss, give the file name. Okay, so I give the file name truss. That is our problem is this is analysis of this is the analysis of truss of 4th experiments. I'll give the name of truss 4 and the location. Already I told you that you have to locate all this data in D drive. So already you have made the folder in D drive. So location already directly it is taken D SA2 lab. Okay, or you can click here from where you can select this locations. Already there is a SA2 lab selected. Then you can see that once you click on truss, it will give the definition of truss. It is a structure consists of truss member which can have only axial member forces and no bending in the members. Now the length unit is meter. Already we have to keep this is in length is in meter, force unit is in kilonewton, and click on next. Click on next. Okay. And always we will go with the anti-motion, that is it is already there, so we will go with the anti-motion. Click on finish. Once you click on finish, there will be the new window will appear there, and in the middle of this, in the empty page, you have to create a model of truss. Okay, so now we'll click on the first task is that we'll have to click on the default grid to create a geometry in this empty space. And here you can see that there is a modeling. We are in the modeling and we have to follow these 3 steps, that is the geometry, general analysis and print. These 3 steps we have to follow. Now we will create a geometry first. The first step we will create a geometry. So now we are there in the geometry. Now first of all, our first step is that we have to enter the nodal coordinates. So before to proceed this, always we have to find out the nodal coordinates for each node. Okay, so we will enter the nodal coordinates. So for node 1, the coordinates is 0, 0, 0. So 0 enter. Coordinates of node 2, that is node B, is 4, 0, 0. So 4 enter. Then coordinates of node 3, it is 0, 3, 0. Is 0, 3, 0. And coordinates of node 4, it is 4, 3, 0. Okay. So in this way, here there should be 3. So okay. So we'll get the 4 nodes. There are 4 nodes and there are 4 members. So once you enter the nodal coordinates, you get all 4 nodes. Okay, but your nodal coordinates should be right so that you'll get the right answer. Okay, once you enter all the nodal coordinates, click on the empty space, and from here you select the option of the front view. Okay, once you can see that there are various options. I told you the very first experiment from which we have to select this option, that is the front view, because from the front view we can see the various loading on the your structure. You can see the various supports on your structure. So always you will have to select the front view option. Okay, and once you click on this option, you can see in this where X is in the horizontal and Y is in the vertical, and this is the two-dimensional structure. It is a two-dimensional structure. Okay, so all the four nodes we got by entering the nodal coordinates here. Now, with the help of the add beam option, we click, you can see in the top on the side, you have that option, that is the add beam option. So we will click on add beam option. Okay, click on add beam option and join the members by using this option from various nodes. So first of all, as we are doing in the skeleton diagram, we are giving the bottom member, that is the horizontal member, as first, then vertical, and then inclined. So the same sequence we will follow here so that you can compare your result. Okay. So there is no bottom horizontal member. There is only the top horizontal member. So first of all, we will draw that member. Okay. So always I told you that what will be the joining from left to right and from bottom to top. So that will be your first member. Okay, so first member we will join. That means this will be your first member. So this is your first from left to right. Once you join these two nodes, it will appear here. You can see that beam 1, node 3, node 4, because this is your node 1 and 3. Bottom node is node 1, then bottom node, right node is node 2, top third 3, and top में right में 4 है. Okay, so this is a node A, node B, that is node 3, node 4. This is the first member. Okay, then the second member is vertical member. So left side we will join the second member from bottom to top. Then the right side from bottom to top, the third member will join, and there is only one inclined member, that is the member AD. If you see in the figure, member AD, it is the inclined member. So again from bottom to top. So in this way, we have drawn the modeling of truss. We have drawn it, the model of truss. Okay. So now this is the four members. With the help of this add beam option, we have joined the four members. Now, once you have created this modeling, what you have to do? We have to give the property to this truss. Okay. So as you know that in the last problem we have analyzed the truss. That was a simple truss where we have gives the properties to this model, to this truss, and that property will include the type of the material, and we are providing the angle sections. Okay, so that we have to give the property. So geometry is over. Okay, geometry is over. So once this geometry is over, we will click on general. So click on general. Once you click on general, okay, the new window will appear here. Okay, geometry is over. Then say this steps we have to follow: geometry, general, analysis, and print. So geometry is over. Click on general. Once you click on general, the new window will appear there. From this option, you can see that there are various options are there, from which we have to select the section database. Okay, so while analyzing your truss, always we are selecting a option of section database. Okay, so after clicking on general, you click on section database. Once you click on section database, there is a window will open, that is a steel table you can see. So from where we have to select the option of Indian. We have to select option of Indian. You can see the various countries are there. So from where we have to select the option of the Indian. So you just click on Indian. Once you click on Indian, there are various angle sections are there. Okay. So already I told you that if you click on Indian, which section you have to select. Generally there is a truss, there is an angle sections are to be provided, and material is steel. So we will select the angle section. So click on angle section. Okay. Now once you click on angle section, now from where if you click on view table, you can see this view, this table. This is a steel table, and there are various angles. So with the continuation of this, what we have to select? We have to select the angle section. So you can see the table here, where you can see that there are various angle section specifications are there, and you can see that the thickness, area, the D and B is given. So in our given problem, which data is given here? There is a area is given, and the area is for all member area is 500 mm square. So area is 500 mm square, area is given. So for all member it is given in mm square. So in the table here the area is in centimeter square. So first of all you convert that area in centimeter square. Okay, so 500 mm square it is 5 centimeter square. So for 5 centimeter square area we have to select the angle section. So already I told you that either you select the area more than given, or it should be equal to that, but it should not be less than the given area. Okay, so from this table you have to select that area, and accordingly you have to provide it. So here I can scroll it up and down, and I can select the area for 5 centimeter square area. I have to select here. So here I am not getting exactly 5, but it is nearly equal to 5, that is 5.07. I can select that area, and accordingly I will provide it. So if you click on this REC number, so you'll get that. So it is ISA 45 by 45 by 6. You'll get for the 5 centimeter square area. And for all members the same area is there. So it is not required to select for the angle section for the various areas, because for all areas the angle section will be same, because the area is same for all members. But if the area is not same, what you have to do? You have to see that area, and accordingly you have to select that angle section. So a single section, angle section ISA 45 by 45 by 6 will be provided for all members. So you have to select the single section, select, click on select, click here again. Okay, if you click here again, it will be added in your list. Okay, so this is added to be added in the list, and the material by default it will take this T. Okay, so we have selected the angle section, we have selected the material. Once it is done, you click on close. Click on close. Now what is the thing? We have to assign this property to the complete truss. For whole truss, we have to assign this. Okay. So we'll select. Already it is to be selected with the help of this drag option. We will select the complete truss, or we can select with the help of the beam cursor. We can select it, or for all members the same area is there. We will select this with the help of the this drag option. Okay. Once it is red, means all this truss is to be selected. So this is blue, means it is to be selected. And what is the assignment method you have to use? The assignment method is assigned to selected beam. Okay, so assigned to selected beam, already it is highlighted. So you just click on assign. Okay, it will ask you that the assignment method you have chosen is assigned to selected beam. Do you want to proceed? Click on S. Click on S. Okay, once you click on S, this property will be assigned. R1 property will be assigned to whole member R1, R1, R1 and R1, because same member for all members, same property is assigned, because area is same for all the members. Okay, so in general we have given the property, specification is over. Okay, general, these are the steps we are following. So general, properties over, specification is over. Now what is the next? Next we are giving support. Okay, we are giving the support, and then we are going to load and definition. So click on support. What you have to do? We have to create a support. We have to create a support. So as you can see in the problem, there are rim support and the roller support. So these two supports we have to create. So after this, we will click on create. So click on create, by default it will take the first option, that is a fix, but we have to create a pin support or hinge support. So we will click on pin. Okay, so as you click on pin, the pin, it is hinge support, is listed in all the direction, fx f5. What you have to do, you just add it in your list. Okay, so that pin support is added in the list. Then again, we have to create a roller support. Then click on create. Click on, what do you mean by roller support? In the stat, it is called as fixed bot. Fixed bot. So click on fixed bot, and if you see the support which is to be there at node C, that support, that is the roller support, so it is stay in y direction, but it can free to move in x direction. So degree of freedom for that case it is 1. Okay, only in node C. So it can move or it can translate along x direction. So when we are going to create a roller support, it will always ask you to that in which direction you have to release. So you just click on fx. Click on fx. Okay, you have to release in fx direction. So click on release in fx. And in case of truck, there is no bending moment. So there is no need of click on MZ. But when we are going to create a same supporting frame or beam, there is a moment, so you have to click on MZ also. But here there is no bending moment in the member, there is no rotational displacement. So there is no need of releasing MZ direction. Only you have to release in FX direction. So once you click on this, release in FX, click on add and close it. Okay. Now these two supports we have created in the list. So one by one we will assign this. So the hinge support is at the bottom node at node 1 and node 2. So with the help of the node cursor, we will select the node. Okay. We will click on this node. We will click on this node. Okay. So these two nodes are selected. We will select the support. Okay. We will select the support. So these two nodes are selected. This should be selected. If the blue means this is to be selected. Okay. Now it will ask you the assignment method. What is the assignment method we will choose? We will choose the assignment method is assign to selected node. Okay. So assign to selected node, assign. So assignment method you are choosing is assign to selected node. We want to proceed here. Click on add. So you can see that this two support is to be assigned there. Now at node 3. At node 3 there is a roller support. Okay. And node 4 is your free node where there is a load is active. So we will select this support. We will select this node with the help of the node cursor. Again, it will ask you the assignment method is assigned to selected node. Click on assign. Okay. So you can see that the roller support is assigned there. Okay. So this is a support we have assigned. This is the support we have assigned to the truck. Okay. So this is all. Then we will click on load and definition. We will click on load and definition. So click on load and definition. Okay. Now we have to give the load. And in this load and definition only there will be change. Up to this, your problem of the analysis of thrust will be same. And the effect of temperature condition and effect of lack of feed condition will have to give in this step, that is in the load and definition. So we have click on load and definition, click on load case details, click on add. Click on load case details, click on add. So what are the load cases are there that we will add in the first load case? So our title is load case 1. Loading type is dead load we will select. So this is the title load case 1, and in this load case 1 we will give all the loading conditions. Okay. So click on add and close the window. So once you click on this, there will be this load case is there. In this load case we have to give the nodal load, we have to give the temperature load, and we have to give the lack of feed load. Okay. So we will click on load case 1, click on add. Okay. Once you click on load case 1, click on add. This is a window will open there. From this we have to give the loading to one by one. So first loading will be the nodal load. There is a nodal load at node 4 or at node T. Okay. X direction there is a 50 kilonewton load, and Y direction there is a 100 kilonewton load. Okay. So as there is a nodal load, okay, load is acting at node. So we will select this option, nodal load. Okay, we will click on nodal load. There are two options, node and support displacement. So from this, node is highlighted means we have to assign a load at node at that joint. So X direction there is a 50 kilonewton load, and the Y direction there is a 100 kilonewton load. So X direction, right direction load is 50. So we'll write it 50 kilonewton load. And Y direction there is a load of 100 kilonewton, but it is in the downward direction. It is in the downward direction, so we will write it minus 100. It is in the downward direction. So downward, so we are taking the sign convention is minus 100. So we have given the X direction load, we have given the Y direction load, where we have given here at node. Okay, so you have to add it in your list. You have to add it in your list, but don't close the window. Add it in your list. That nodal load is added in your list. Nodal load is added in your list. Okay. Now the two conditions. You have to analyze the truss for the two conditions. So what is the first condition? The first condition is temperature. So temperature increases by 50 degrees Celsius. So as you know that if there is a temperature increase, if there is a rise in temperature, compressive force is developed in all the member. If there is a fall in temperature, tensile force will develop in each member. Okay. So we have to give that increase of temperature. Only we have to give that how much increase is there. But the stat will directly assign that force. Directly, the stat will calculate that force and it will directly assign to that all the members. Similarly, the lack of fit. There is only the effect of error. Fabrication error is only in member AD. Okay, and it is given that there is a member AD is 5 mm long due to the error in fabrication. So that effect also the stat will calculate that force and it will be directly it will assign. So if there is a increase in, if there is a member is too long, if the member is too long, then there is a compressive force will be assigned to that member. So this is our. Now what we will give, we will have to assign the temperature load. So in this option, in all the option you can see here. Okay, there is a first option is the self weight or the nodal load or the member load. If there is a member load, we are selecting this option. Then there is a various loading conditions are there, from where we have to give the temperature load. Okay, so you can see that there is the option of temperature load. You can see here. Okay, so we will just click on temperature load. Once you click on temperature load, there are two options, temperature and strength. There are two options, temperature and strength. So for temperature effect, we have to select the temperature, and for the lack of fit effect, you have to select this option, that is the strength. That is the strength, because there is a either there is a member will be too long, or either there will be the shrinkage, or either there will be the expansion. Means that means strength. So for the effect of temperature and for the lack of fit effect, you have to select only this option, that is called as the temperature load option. So you have to click on temperature load. Okay, once you click on temperature load, there will be highlighted temperature. So it will ask you that how much increase of the temperature there. So whatever the increase is given, that you do. So there is a, you can see that there is a temperature change for axial elongation, temperature differential from top to bottom, temperature differential from side to side. It is not given the temperature differential from top to bottom or side to side. What they have given that there is only the temperature change for axial elongation, and how much the temperature change is there. There is a 50 degrees Celsius temperature change. Okay, so only what you have to write down here, only you enter the value of increase in temperature. So that increase is, that is in the problem, it is 50 degrees Celsius, so you just write down 50 degrees. Okay, once you do this 50 degree हो गया, you just click on add. Click on add temperature 50 and close the window. Okay, temperature 50, close the window. Don't close the window. Okay, again we have to give the so with the continuation of this, as we have added the nodal load and we have added the temperature load in the load case 1. So again I will click on load case 1 because by mistake I closed that window. So again you click on load case 1 and click on add, so that window will appear again. So again you select the temperature load. So temperature load we have given. So in the same temperature load there is the option of strength. There is the option of strength, means there is the option of giving the effect of lack of fit effect. Effect of lack of fit effect. So we'll click on strength and we'll click on strength. Once you click on strength, there will be the option of initial axial elongation plus and shrinkage minus. Means there is a, if there is a member too long, the value will be plus, and if the member is too short, the value you have to enter it minus. Okay, so what is the lack of fit effect is given? The lack of fit effect is given in member AD, that it is an inclined member, and it is given that it is a 5 mm long due to the error in fabrication. Okay, 5 mm long it is given. So that you have to convert into meter. That you have to convert into meter. Okay, so it is 5 mm long. So that answer that you have to enter the value in meter. So it is 0. We will enter that value and there is a 2 long, means that value will be plus. So 0.005 meter that we have to enter here. Okay. So there is a lack of fit effect. Where you have to apply assign this effect, you have to assign only in the inclined member, that is the inclined member AD. Okay. So we will enter that value, we will click on add, then it will be added in your list. Okay, so this 3 is to be added. First is the effect of nodal load, second is effect of temperature, and third is effect of lack of fit. Okay, so temperature effect and the lack of fit effect we have to give in the load and definition itself. For nodal load plus the temperature load plus the lack of fit effect. So for temperature load, which option you have to select? We have to select the temperature load option, from where there are 2 options. One is for temperature and second is for lack of fit, is called as strength. Okay. So in this way we have completed. We have given all the loads to the truss. This is a nodal load. First is a nodal load. Second is the temperature load. As there is a rise in temperature, the compressive force we developed in all the member. What we have to do in the software? Only we have to enter the values, that we calculate the magnitude of force, and we give the nature of force also. Similarly, we'll give the effect of strength. How much the strain effect is there? Whether it is a elongation, shrinkage. Stat will calculate directly the magnitude of the force and the nature of force. Okay. Now there is a question mark. We have to assign it to the joint where you have to assign. So first is the nodal load. So where is the load is acting at free node. So our free node is this is the node D is our free node. Node D is our free node. Okay. So node D is free node. So with the help of the node, first of all we will select this. Then with the help of the node cursor, we will select this node. Okay. This node with the help of the node cursor, the node is selected because at this node there is the nodal load of this. Okay. And then assignment method is assign to selected node. Click on assign. Click on assign. You can see here. Okay. So you can see the nodal load is to be applied, to be assigned at this node. Okay. Now you have to apply the temperature load. So where due to the temperature, due to the increase in the temperature, the compressive force will be developed in all the member. पूरे member पे developed होगा, इसलिए आपको पूरे member को select करना है. Then go to drag and we have to select this. So we'll select this. We'll select all the members. Sorry, there is a we'll go with this option. So we'll select all the members here. Okay, the all members have to be selected. We'll click on this and assignment method is assigned to selected beam or plates. Click on assign. Click on assign. It will ask you that you want to proceed. Click on S. Okay, so okay, you can see the nature of force. You can see this is a blue means this is a you can see that this is the compressive force. You can see the compressive force is to be developing in the member. You can see the nature of force. Okay, and this is a question mark. Mark is not there means it is to be assigned successfully. Okay, now what we have to give the lack of fit. Lack of fit if it is not for all the member. Only there is a lack of fit effect only in the inclined member. Member 80. So we select this with the help of this node beam cursor. We'll select this member. This beam is to be selected. With this member there is the effect of lack of fit. Then assign to selected beam or plate. Okay, assign. You can see. Okay, there are lack of fit effect and also there is a temperature effect. And again, there is a too long member, so there is a compressive force. So once it is done all, once it's done all, okay, and there is a change of the analysis. Only there is a change in the shape of the load and definition. All the temperature load and the lack of fit effect load we have to give in the temperature load itself. Okay. Now, baki there is a otherwise there is a no difference as such. Okay. So this is everyone. So we have finished all the tasks. We have finished all the steps. Then what is the next? We click on analysis and print. Click on analysis and print. Once you click on analysis print, this window will open. Post print, pre-print. So we are in the pre-print option. So always there is a no print. You just click on add. Okay. You click on add. If you will not click on add, the analysis will not be performed. So you just option will be always no print. Click on add. So once you click on add, there will be option of perform analysis. It will analyze. It will perform the analysis. Then click on close. Okay. Now click on post print. Click on define commands. What the result we want? We want the result of the joint displacement. We want the result of member forces and we want the result of support reaction. Same results we have to analyze. We have to same results we have to verify with the manual method. Okay, and the stiffness method will give you the result of the joint displacement. That's why we select this option also. Okay, so click on joint displacement. Click on add. Click on member forces. Click on add. Click on support reaction. Click on add. Okay, these three results we want. So we click on this and once you click on this, once you add it in the list, you close the window. Then bring joint displacement. Always the option is always while selecting is assigned to view means assigned to the structure. जहाँ पे joint displacement निकालना है वहाँ पे वो joint displacement calculate करें. So print joint displacement, click on print joint displacement, click on assign to view, click on assign. Okay. Then click on print member forces, click on assign to view, click on assign. Yes. Then click on print support reaction, click on assign to view, click on assign. Okay. So all these are green right mark means it is to be assigned successfully. Okay. Now once you we have done all this, you just click on the middle of the empty space, click on analyze, click on run analysis. Okay, structure has been modified, save. There should be zero error, there should be zero warning. Then only the program will run. If there is a warning, the program can be run, but if there is an error, there will be that error. You have to first of all, you have to eliminate that error, then only you can see your analysis results. Then click on view output file, click on done. So this you can see the result. This is the input and you can see the results here. Okay, where you can find out the joint displacement values. you can see the joint displacement values, that is the X translation. So at node D means at node 3, node 3 and node 4. So node 3 there is the roller support. You can see node 3 पर roller support है तो node 3 पे X translation मिलेगा, that is comes out to be 1.29 centimeter. In manual method there may be some difference, okay, point का difference हो सकता है. And at node 4 that is the node D, free node है, वहाँ पे दो टाइप की डिस्प्लेसमेंट पॉसिबल है, इसलिए एक्स ट्रांसलेशन आ रहा है 1.53 एंड वाई ट्रांसलेशन आ रहा है -0.21, -0.21. So that all are in centimeter we got the result. So there is a 3 degree of freedom, 3 value. In at node 3, at node C there is a X translation 1.29, at node means DF1, DF2 and DF3. So DF1 is 1.92, 1.29, DF2 is 1.53 and DF3 is -0.21. Okay. Likewise, you will get the result. Or in whatever you will get, if you go give the free node is 1, 2, or 3, that sequence can be changed, but your magnitude, your answers will be right. The sequence can also be changed. Okay. Then this is the joint displacement value. Then you can see the member and forces. Okay. These are the member and forces. You can see the member and forces result. Okay, for member 1, actual force is 0. For member 2, it is 62.36. Member 3, it is 137.50. And member 4, it is 62.50. Okay, in this way you get the result. And you will get the support reaction. You will get the support reaction. Okay, if you add all the y direction force, the y direction force, it should be the addition should be 100, and the x direction is plus 50. You can say it is minus 50. You can say it is minus 50, and this should be plus 100. This should be plus 100. In this way, you can see the result. You can compare the result with the manual analysis. Okay, the same results you will get, or you will get with some of the. There may be some error. There may be some error means there may be some the difference of point difference there may be. Okay, that can be considered. But if you consider the y direction, if you add the y direction force, it should be, the addition should be plus 100. Addition should be plus 100. Okay, so you can give this change, that is summation fy equal to 0 and summation fx is equal to 0. So this is the output you can see. This is the output you have to say in what 5. Okay, and already I told you in too many times that what you have to keep here and what you have to delete. You have to keep only the input and the output. Okay, output. In the output, you have to keep the output results like the joint displacement result, like the support reaction result, and like the member input result. Okay, so here I will stop now.